Okay, so this is separate compilation. What we're talking about is separate compilation. This is chapter 12. Now, what we are going to do, when we implement the programs from now on, we're going to do that over 3 different files. One file will contain the class declaration, and we're going to call that the .h file. So in the simple example we're going to write now, student class example, and we're going to have student.h. The student.h is going to contain the class declaration, and then we're going to have a second file which is called student.c+cpp, so C++, and that will contain the class implementation. And then we need a third program, which is the main program. The main program will use that class. So now we're going to have the interface, the implementation, and the application. Interface and implementation, they belong to the student class. The application is your main. Okay, and this is a very typical set layout of writing C++ programs. Okay, so now let's go back to the simple example that we're going to write. But now we need a header file, right? So the header file .h file will go inside the header file. We did not use this directory before. Usually we just write our program inside the resource files, right? But now the .h file, the header file, .h stands for the header file. The header file will go inside this directory. So now I'm going to right click, add a new item. And the new item is not a C++ file, it's a header file, .h file. Okay, so I'm going to call this student.h. Here we go, I have student.h now, right? So inside this student.h, hash include iostream. Okay, and then we have class student. We're going to have a very simple class, which just to illustrate the concept of separate compilation. So we're going to have maybe there is string name. So now we need hash include string. And then maybe there is a string ID. You can have it as an integer, it doesn't make a difference really. Okay, and then public. We need a constructor, right? Student. So just set the name to someone and the ID to /. And then let's have a function like just print out. And we're going to implement this print out somewhere else, so this is going to be a void function. And then let's have a function read student. Of course, this can be operator overloading, just like what we did previously, but I just want to write it quickly. Okay, that's it. We're done with the interface. That's the only thing you'll have in the interface. You can, if you wish, if you have a short implementation of the constructor, you can include it in the interface. It doesn't harm, but typically for all other functions, you're going to implement them somewhere else. So we're done with the student interface. Now we're going to go to the resource files, and I'm going to add a new item. And this new item is going to be a C++, and I'm going to call it student. But this is student.c++ now. So I have student.h and I have student.c++. Okay. So now this is student.h. I need to copy this. Now I'm going to implement all the functions that I have in the student. But I have to start by saying the following, which you did not see before. Now I'm going to hash include student .h. And let me pause here for a minute. Couple of rules in C++. Now, since those are in 2 separate files, you have to write the hash include statement at the top. And what C++ will do, when the compiler, in fact something called the pre-compiler, it's before compilation. Just when you hit the compile, before the compilation process, what C++ will do, it will actually copy this whole thing. This is what it will do. Exactly this. It will search for your hash include student.h and replace it. But this will happen behind the scenes. You will not see it. Okay? But what we're going to do is this. And C++ will going to take care of it. So it's as if it's in the same file. Now the second rule is, when you hash include your own files, you don't use the curly, you don't use the pointy brackets. So this is not allowed in C++. This is only allowed for built-in classes, not for user-defined classes. In user-defined classes, this is what you do. Control-Z, Control-Z. Fine, so those are the two rules. So again, there's something called the pre-compiler, and the pre-compiler, whenever it sees this statement, it's just simply going to copy this and replace it. Yes?
The student.cpp, we don't need hash include string or hash include string. We can just use hash include student.h.
That will also work. Yes, that's also fine. Yes. So your question is, if we're going to copy this anyway over here, why do we need hash include string and hash include? Yes, that's a good point. But anyway, C++ will know that this is replicated and will not make another copy of it. And I'm going to come to this in a minute. Good question. Okay. So now what do we need to do? We need to implement those two functions. We only have two functions to implement. And of course, we implement them using the same approach as we did previously. What do we have? Name and ID and line and line. Again, you can be fancy about it, but just for the sake of time, cn name, cn ID. Enter student information. Yes, that's it. Okay, so now what do we have? This is called the this file is called the implementation. This file, it has two names: the header file or the interface. So we have the header file or the interface.h, and we have the implementation, which is called obviously the implementation file. Okay. If you have friend functions inside this class, you also implement them over here. So it's exactly as we did previously. There's no difference, but the only difference is, instead of implementing the functions in the same file, we're implementing them in a separate file. That's the only difference. Okay. Why do we do this? As I mentioned, we do this for the sake of abstract data types, because the user is only concerned with this. I need to know what's the name of the function, what to pass it, and what does it return. How is it implemented internally? As a user in main, I don't need to know. Okay, so if I'm using the vector class, again, as I mentioned, if I'm using the vector class from C++, I don't need to know how is it implemented. I only need to know that there's a function called pushback, and what does it receive and what does it return. Okay. So now there's one more file to add, which is the last file, which is called the application, which is the main. Okay, so add a new, I'm going to call it main. So now we have main.c++. Okay, now main.c++, guys, again is going to use the student. So we're going to do the same thing, and we're going to hash include. We're going to hash include the students. We use cn and cout over here, so we need to use the namespace.
You copied it twice for student.cpp.
Okay, so now in main, since we are going to use the student class, again we have to hash include. So now this is void main, and I'm going to have student type s1, and then what's the name of the function? S1 dot. And C++ will know that there's something called a student because we did the hash include over here at the top, right? So let's remove this hash include. And now let me try this out. S1 dot. C++ doesn't know what I'm talking about. Okay. So now we are informing C++ that look, I'm using a class which is called student.h. C++ will know that this is a user-defined function. This is a student-defined class because there's the double quotation, right? It's not a pointed brackets. Okay, so now s1 dot read student, and then s1 dot print out student. We're done. Full stop. خلاص. What is this called? This is called the application. Okay. So how do you compile? You just hit compile and C++ will take care of it. Build project or compile. You can, if you want, go to one file. I just want to compile the student class without main. So I can go to build and click on compile. This is separate compilation because now I did not compile the whole project. The only thing that I have compiled is the student. Can you see this? I compiled only one file, so this is why it's called separate compilation. But if you go to main over here and you just simply say build project, build solution, C++ will compile the student.cpp and it will compile main.cpp. One more thing, the student.h, C++ does not compile it, so you cannot go to this file and compile it separately. There's no compile. Header files, you don't compile them separately. What you compile instead is either the implementation and you also compile the application. But header files, they will be compiled at this point because at this point you're going to hash include students, right? So if there is anything wrong with it, C++ will catch it at this point. But you don't compile header files. What you compile is this. But there's one last thing to mention and we'll be done with this part. Yes, Jad, very quickly.
If you want to debug it, it's the same way. If you want to debug one part, if you want to step into it, it will send us to the...
It will send us to that file, yes. So now Jad is asking, if you are at this point and we want to step into, what will happen? Debug, start debugging. Step into. It will send us to that file. Okay? Step out. Stop debugging. Where are we? Did we stop that debugging? Yes, we did. Okay. Let's go back to main now. But now, look at this. Let's say that by mistake I did this twice. In fact, you're not going to do this by mistake, but just to let you know, in real life projects, you don't have one class. Now we have one class called student. In real life projects, you have, just like the project that you're going to work on soon, you're going to have library item, you're going to have a book, you're going to have student, staff, so many classes, and you're going to do so many hash includes. In some cases, you have one object which hash include, you have object 1 hash include object 2, and object 2 hash included object 3. And then in main, you hash include object 2 and you hash include object 3. But object 2 already hash include object 3. So now you end up with 2 copies of object 3. The point is, if you end up with 2 copies of one header file, C++ will not compile. Let's try this. Can you see the fail over here? What does it say? Class redefined. Because as I mentioned, guys, what C++ will do, when it will see the hash include, it will just simply do this. It will do it once, and then it will do it twice. So now the class is being redefined. Class student followed by class student. Control Z, Control Z. Okay? So again, as I mentioned, in real life, if you have class 1 hash includes class 2. And then in main, you say hash include class 1, and then you say hash include class 2. Now let's assume that inside this class you already did something else like hash include class 2. You have hash include class 1 in main, and I also have hash include class 2. But I didn't notice that class 1 itself has a hash include of class 2. So now in main, how many instances of class 2 did I end up with? 2, and it will not compile. Okay, so this is you will not encounter this if you only have one class like our simple scenario, but if you have more than one class you might encounter this. So is there a way around it? Yes, there is a way around it. There is a very simple solution around it. Let's keep this as is now, and let me show you something that you did not see before. Smiles? Okay, how to solve this? There's something in C++ called hash if not defined. I'll explain it in a minute. If not defined, and you come up with any name. Usually the name that I'm going to come up with now has to do with my student class. This is student.h, right? So usually I write something like this, student. I cannot write .h because this has to be one continuous word. Usually it's written like this, all in uppercase. So student.h. If not defined student.h, then define it. Okay, what's happening? What's happening is the following. I'm going to introduce over here a new quantifier. This is a new word, this is a new variable, a new quantifier that is not there before. So I'm going to ask the question, has this been defined before? It's not been defined before. This is the first time that we see it, right? So if not defined, what does it return? Does it return true or false? It returns true, it's not defined, right? This is the first time C++ will see this word. And we're asking the question, if not defined student.h, would it return true or false? To return true, it's not defined. If it's not defined, what do we want to do? We want to define it. طيب. Now, when we have if not defined, at the end over here, we have to have end if. Yeah. So this is like an if statement, okay? طيب. Now, luckily, it always has this structure. It doesn't look anything else. So this is always, we're going to use it this way. Let's go through the logic again now. We're going to ask the question. C++, this is the first time that it compiles the program for the first time. And then we ask the question, if not defined student.h, C++ did not see student.h before. This is the first time that it sees it. If not defined, yes, it's not defined. So if it's not defined, what I'm going to do is the following. I'm going to define it, and then I'm going to declare my class, and then I'm going to have end if. Okay? But now let's go back over here. Let's keep those two statements as is. Now, we do the first hash include. So C++ will go and it will copy this. Before copying this, it will see that there is this if statement, and it will answer the question. If not defined student.h, no, it's not defined. This is the first time I see it. So what C++ is going to do, it's going to define it, and then it's going to take this. It's going to take this and copy it to the location of the first hash include statement. And the C++ will continue compilation. What's the second thing that it will see? Another hash include. So now it will go to the student.h. It will see an if statement and it'll ask the question. If not defined student.h, what's the answer, true or false? It's false because now it's defined. Now it's defined. So since the answer is false, if it's not defined, false. It is defined. So we're not going to enter the if statement. So if we don't enter the if statement, there's nothing to be copied over here. Nothing is copied. Okay, so now let's keep it as is. Let's keep them as is, but now we have included the extra, if not defined, define, and let's compile.
Because of the names,
With the spelling of hash.
define. The spelling.
There are 2 different spellings.
So hash defined.
La student type over here.
Second one.
Yes. No, hash define is fine. There was a typo on student in the second one. خلاص, it's running now, right? Debug, build solution. It's working now. So now, no matter, even if by mistake you hash include the student many times, it doesn't make a difference, because only one copy will be copied to the implementation file. So now in all the .h files that you're going to see from now until the end of the semester, you always have those 2 at the beginning of the file. They're given a name. They have a name. It's called directive. The hash if defined is called the directive. Let me show you that. Multiple classes. Okay, so in this example, instead of student class, we have a date time class, something of that sort. And this hash define, it's called a directive. So now this is what we had exactly. In our case, between those 2 lines, what we have is the interface for the student class, and that we have over here is the interface for the time class. Now, if it's not defined, if it's true, then 3 things will happen. Look at this, guys. This is a nice illustration. If it's not declared, if it's not defined, 2 things will happen. It will be defined, and this will be copied to the implementation file. Now, if it's already defined, then this is going to be skipped, and this is going to be skipped, and we're going to jump all the way to the end if, which means that we'll not end up with 2 copies of the same header file. Okay. So this is the identifier. This is called an identifier. I was searching for a proper name for it. So the student H is an identifier. So this is an identifier that you're trying to declare or define. It's defined, it's not declared. And this is called a directive. Maybe the name is not too important, but it's nice to know it. So this is the hash if defined, hash defined. All of those are called directives. Again, let me just re-emphasize that the hash include and replacing it with the actual interface, this is a pre-compilation process. So you hit compile, but before the actual compilation, the code will be copied. But what happens during the compilation? Of course, you know this from programming 1. It will check for syntax errors, and then it will convert it into machine code. Eventually, it will be converted into machine code, which is executable code that you can run. There are other things in between that, but you can't skip them now. Okay, so that's it. Any questions?
Sir,
Yes.
we have more than one header file.
Yes.
The implementation of the functions, does it have to be in another C++ file?
Yes. So now let's assume that you have two classes. One is called student and one is called course. So you're going to have course.h, course.cpp, student.h, student.cpp. And then in the main, you're going to have hash include student, hash include course. Okay? This is a very typical use, and as I mentioned, from now on, you're going to see that in all the H files that you have. Although in the lab today, we're not going to ask you to do this, but if you want to do it, it would be nice as well. That's up to you, really. Any questions?